Alright guys, so this is a section on constant rate of change and slope. Our LAQ for today is how do we find the constant rate of change for a linear relationship and find the slope of a line. So we're going to first start off here with example 1. It says the table shows the distance traveled on a zipline tour. Find the constant rate of change between the quantities. So if I take a look at that, I'm going to look at the time and I'm going to look at the distance. So on the top I have time. So I have 2, 4, 6, 8, 10, and 12. And on the bottom I have the distance, which is 12, 24, 36, 48, 60, 72. So if I look at the difference between 2 and 4, I'm adding 2 every single time. Okay, so add 2, add 2, add 2. The bottom, what I'm doing is I'm adding 12, so add 12, add 12, add 12, add 12, so on and so forth. So what we're going to do to find the constant rate of change is we are going to find the unit rate to determine the constant rate of change. So we have the change in distance over the change in time. And basically you're going to do your y over x. So this is going to be technically my x, this is going to be my y. So I'm going to put my y over my x. So I have 12 feet, so the change, so 12 over 2. I simplify that, I get 6 feet per second. So then the constant rate of change is going to be 6 feet per second. So that's how I find it using a table. So example number 2 says a circular design on an internet advertisement has 2 circles, one that is decreasing in size and one that is increasing in size. We're going to find the constant rate of change for the radius of the circle 1 in the graph shown, and then we're going to interpret the meaning. So if I look here, here's my graph, and that graph should be on your paper. So the first thing I'm going to do, there's 2 different steps here. So step number 1, so step 1, I'm going to choose 2 points on my circle 1 line. So here's my circle 1 line. Circle 1, we're going to call that the green line. Oh, let's make that a little bit better. So we're going to call that the green line. So I have to select 2 points on that green line. So if I select 2 points, I can select this one right here and that one right there. So I'm going to write down my point values there. So we can pick the point. So the first one is going to be 2, 5. And the second one is going to be 6, 4. Again, 2, 5, 6, 4. All right? And then what we're going to do is we're going to interpret what do they mean. Well, this one means the 2 is going to, so 2/5 represents 2 seconds per 5 centimeters, and then the 6/4 represents 6 seconds per 4 centimeters, okay? So 2 seconds per 5 centimeters and 6 seconds per 4 centimeters. So we're going to have to find the rate of change between the points. So we're going to go ahead and say rate of change, just like we did on that last one. We're going to put my y over my x, okay? So we're going to say the change in the radius. So the radius here is the y, so we're going to say the change. So we're going to go 5 minus 4 all over, oh sorry, not 5 minus 4. Let's try that again. 4 minus 5 all over, and the 4 corresponds to the 6, so I'm going to do the 6 minus 2. Okay, so I have 4 minus 5 over 6 minus 2, and then I figure out what that is, and I get negative 1/4. So I have to interpret what does negative 1/4 mean. That means negative 0.25 centimeters per second. And again, I'm trying to find the rate of change here, and I have to say, okay, well, what is this problem about? The problem says find the constant rate of change for the radius of circle 1 in the graph. So then my answer is going to say the rate of change of negative 0.25 centimeters per second means that the radius of the circle is decreasing at a rate of 0.25 centimeters per second. So I'm not going to write all that down because I don't have enough room here, but we're going to say decreasing at 0.25 centimeters per second. So again, it's just like when we were talking about if we had a negative rate, it would be decreasing. If it's a positive rate, it's increasing. So concept summary, again, rate of change, just like we did before in a couple of the other sections. The rate of change, if it is positive, in real life, that means that it's an increase, and in a graph, it's going to go from the bottom left to the upper right. If it is a negative rate of change, it's going to be a decrease, and it's going to start at the top of the left and go down as you read to the right. And rate of change of 0 means that there's no change, and it's just going to be a whole straight line, horizontal straight line across. So we talked about rate of change, and rate of change and slope kind of go hand in hand. So our key concept here of slope, so in words, the slope m of a line passing through points at x1 and y1 and x2 and y2 is a ratio of the difference in y coordinates to the corresponding difference in x coordinates. So yeah, all those words you might be like, well, I have no idea what that means. That's okay, because right here we're going to use these symbols. This is what we want. That's what I want you to know. So we have y2 minus y1 over x2 minus x1. Remember, m always represents the slope, okay? So m represents the slope. So x2 cannot equal x1, because in that case I'd get a 0 on the bottom, and that can't happen. So here we have our graph here. So if you ever heard of slope before, you might have heard rise over run. So that's basically what we're doing. We're going to rise up, so our y values over our run values of x here. So if these are my 2 points, x1, y1, x2, y2, to find the rise, I'm going to do y2 minus y1. To find the run, I'm going to find x2 minus x1. Alright, and then, so what we're going to do is example number 3, it says find the slope of each line. So I'm going to go ahead and I'm going to find the slope of this first one up here. So if I look, I have 2 points. I have 8,6 and 4,3. It doesn't matter which one you pick as x1, y1, and x2, y2. That's totally up to you what you want to do. So you just go ahead and pick 2 points. So let's write down our points. So 8,6, 4,3. And I know that my slope formula is m is equal to y1 minus, y2 minus y1 over x2 minus x1. Right, and then I'm just going to label them. To make it easier, I label them. So I can say this one is x1, y1. This one is x2, y2. Right, and then I just take the numbers and I plug them into the formula. So y2 is 3. So I say 3 minus 6. So 3 minus 6 all over x2, which is 4. 4 minus 8. And be careful here, and when you're looking at this, you want to make sure that these 2 numbers are in the same ordered pair, and these 2 numbers are in the same ordered pair. Because if they're not, you're going to kind of mess up your math, and you're going to get some negatives you don't want to get. So I go ahead and I put those in, and I do the math. So 3 minus 6 is negative 3. 4 minus 8 is negative 4. So I have negative 3 over negative 4. Well, I know that 2 negatives make a positive, so this is really 3/4. So my slope of this line here is m is equal to 3/4. That's the work that I want to see. Now, what you could do is you could do rise over run. So if you're given a graph, you can look at it and say, okay, the rise over the run, that's fine. But I want you guys to get used to also doing it mathematically like this, just in case you're not given a graph. So let's say that I start here at this point, and I want to see what the rise over run is. Okay, well, rise usually go up, right? But rise can be up or down in this point. So I'm going to go down. So if I go down, I can say 1, 2, 3. So I go down 3, so there's -3. And then I go over to that point. I'm going to the left 4, so -4. So I have -3 over -4, or a +3/4, because again, two negatives are going to make a positive. All right, so example B here. We can look at this and say, all right, well, let's take the points and let's do that first and then look at the graph. So I have my points -4, 2, and 2, -2. So we're going to make this x1, y1, x2, y2. I'm going to do my slope formula. M is equal to y2 minus y1 over x2 minus x1. Plug in my numbers. So I have 2 minus 2 all over x2, 2 minus -4. So I'm going to figure this out. 2 minus 2 is 0. Oh, so if I take notice there, just looked at it and said, okay, well, 2 minus 2 is 0. That's not right. I forgot this little negative sign here. So that little negative sign can make or break you at this point. So you want to make sure that you're putting that in there. So let's try this again. So -2 minus 2 is going to give me -4. And then I have 2 minus -4, which is the same thing as 2 plus 4, which is 6. And I can rewrite this as -2/3 as my simplified answer. So I could say that m is equal to -2/3. Okay? So let's check to make sure that I did this the right way, because you never know, I might have made a mistake. So if we start up here, we're going to do rise over run. So I'm going to drop down. So I'm going to say, okay, 1, 2, 3, 4. Okay? So this is -4. And then I'm going 1, 2, 3, 4, 5, 6. +6 to the right. So -4 over 6, or I can simplify that down to -2/3. Okay? Because I also can see, oh, well, it crosses here. So I could come down 2, and 1, 2, 3, go over 3, and still get the same thing. All right? So down here, example number 4, it says find the slope of the line that passes through each pair of points. So what you want to do is you have your points here, and sometimes you'll get the graph, sometimes you won't get the graph. It all depends. But in this case, we got the graph. So we're still going to do our m is equal to y2 minus y1 over x2 minus x1. So again, I can label them x1, y1, x2, y2. So I have 4 minus 4 all over 2 minus -3. Now in this case, you might say, well, back in example 3, part B, you said, uh-oh, I have a 0 on top. Yes, that is true. However, in this case, I have my signs correct, so I'm still good. So 4 minus 4 is 0. And then these two negatives make a positive, so I get 0 over 5. And 0 over 5, what that means is that it's just 0. So I can have a 0 on the top, but I can't have a 0 on the bottom. So the 0 on the top just means that I have a slope of 0 or a rate of change of 0. So it means that it's not changing at all. So if I look at this, it doesn't change. It stays the same. It doesn't slope down. It doesn't slope up. So it just stays the same totally across. So a horizontal line has a slope of 0. And that's something that you want to remember. So again, I'm going to say it one more time. A horizontal line has a slope of 0. Part B, again, I want to start off by labeling. So I'm going to say x1, y1, x2, y2. So I have 0 minus 3 over 1 minus 1. Well, if I look at that, if I remember back to my key concept, it said that my x1 and my x2 couldn't equal each other. That's true, they can't. Because when your x1 and your x2 equal each other, it comes out to be 0. So I have negative 3 under 0. And when I have 0 on the bottom of a denominator, it's what we're going to call undefined. So the way that I remember it is if it is underneath, it is undefined. So we're going to say undefined. So my slope, my m, is undefined. Okay? So then that means that if I have a vertical line, because if I look here, this is a vertical line. So if I have a vertical line, the slope is undefined. If I have a horizontal line, the slope is 0. Okay? And we'll kind of do a little activity that will help you remember which one is positive, which one's negative, which one is 0, which one is undefined. All right, so that does it for the section on constant rate of change and slope. If you have any questions, please make sure that you ask me during class so that I may help you out. Have a great day, guys.